So let's graph some exponential functions, and we'll start with some easy ones and then kind of build from there. They're easy if you start with some basic ones. So this is just going to be 2 to the x, so we want to graph 2 to the x. So we have a table of values. And just find 3 key points, and we're going to be using 0, 1, and -1 a lot. So when x is 0, 2 to the x, well, 2 to the 0, anything to the 0 power, this would be 2 to the 0, would be 1. When x is 1, this would be 2 to the first power, which is just 2. And when x is -1, this would be x 2 to the -1, which is just 1 over 2, or 1/2. So those are your 3 basic points. And we go from our origin, which is our 0 in this case. And I just can go 0, 1. And now my points are every 2. I didn't put every 1. Make it a little bit easier. So 0, 1. And my next point is 1, 2. 1, 2. And this point is -1, 1/2. So those are your 3 key points. We could do some more points over here. We don't really need to, but we have a little bit more room on our graph. In other words, how about it when x is going to be 2? What's 2 squared? 2 to, that's 4, so I can put that in. And I even got room I could put when x is 3. What's 2 to the third? 8. So I got a little bit more room on this graph, so I can fill those in. So when x is 3, y is 8. And there we go. So you got a good idea of that graph. Now what happens is this is going to get closer and closer. When x is -2, this is going to be 1/4. Because 2 to the -2 is 1 over 2 squared, which is 1 over 4, which is 1/4. So it actually could see that that's going to get closer and closer. But it's never going to get negative. Because we're always going to have 1 over some number. So when we sketch our curve, all you really need are 3 points to get the contour, but you can try some checkpoints. There's your curve. And it's going to get closer and closer to this line. In this case, what we call this line, y equals 0, we call it, which is the x-axis. The line y equals 0 is what we call horizontal asymptote. And usually you use dashed lines for horizontal asymptotes. And this is the line y equals 0, because every point on this line y is 0. So that's the horizontal asymptote. Now in this case, the a is 1, because there's nothing that we see in front of the 2, so we always understand that to be a 1. What's the domain of this function? It is a function because it passes the vertical line test. The vertical line touches it only at one place. Any vertical line, you can use your pencil and look. Any vertical line will touch that graph only once, so it is a function. And what's the domain? Well, the domain looks like it's going to be all real numbers because it's just going to keep going. Could have drawn it. The thing is that you want to make sure that when you draw these, it always gets closer and closer to the horizontal asymptote, all right? It doesn't get veer away, so sometimes I have a little trouble drawing them. They keep getting closer and closer. Sometimes they veer away. So remember, it's always going to get closer to this asymptote, so this horizontal asymptote. So the domain is all real numbers or -infinity to infinity, and the range, and looks like I'm going from 0 now. I'm not going to be equal to 0, so I have to use an open parentheses. So I'm going from 0, and it's going to go up and up and up to infinity. So there you go. All right. So the horizontal asymptote is y equals 0. The domain is -infinity to infinity. The range is 0 to infinity. And our b, if we look in that form, is going to be 2, but our a would be 1. And we don't have any shifts, so that's why our reference point or our origin is 0, 0. Okay, let's try another one. y equals 3 to the x. So again, I'm just going to try a table of values to get some points. Or from, we call this sometimes a t-chart. Okay, so when x is 0, 3 to the 0 is 1 again. When x is 1, 3 to the 1 is 3. And when x is negative 1, 3 to the negative 1 is 1 over 3, which is 1/3. So those are our 3 key points. We can put those in. So 0, 1. And 1, 3. So this is going to go up a little bit faster here. Out 1, up 3. And back 1, up 1/3. So something like that. And we could try another, well, won't have enough room because if I try when x is 2, 3 squared is 9. So I'm going to be up here a little bit higher. I could kind of estimate. I'll put it up there one more. And there's your curve. And remember your horizontal asymptote is the line y equals 0. And I got to make sure that it gets closer and closer to that. So this is and use these 3 points will pretty much give you the contour of the curve. The 0, 1, and negative 1, and there you go. Now the domain, I'm just going to use D here because I don't have a lot of room here. So the domain is going to be negative infinity to infinity. And the range will be, again, 0 to infinity. Okay? So that's not too bad. And it's just going up a little bit faster because we have 3 to the x power rather than 2. So this curves up relatively fast. This curves up even faster. In other words, as I move from the right to the left, my vertical position is going up. Here it's going up a little bit at a time, and then after I pass one, it starts going up faster and faster. Okay? And this is even faster. And in both these cases, we call this exponential growth. Because as you see, as we move to the right, we're growing exponentially. And as we move to the right, the values of our graph, which are the vertical positions, go up. So this is called exponential growth. If the values were going down, it would be exponential decay. All right? So those are 2 pretty good examples. We're going to do some more, and they're going to get more and more complicated. So please try to stick with these.